For chapter 2, which chapter will cover on the calculation? 2A and 2D. Dia kalau soalan bukan 2A, mesti 2D. Jaranglah soalan kita buat untuk kira ripple voltage. Yang chapter 2C tadi jaranglah. Dia ada calculations, tapi untuk for you guys mechanical background, kita tak suruh kira pun. Kalau ikutkan memang dia boleh kira. Macam tadi saya kata okay, kita skip. Memang boleh kira. Kalau budak electrical memang dia orang kena tahu. But then for us, just you tahu on the theory daripada AC signal pergi ke DC, what happen in between, apa circuit yang ada, apa applications of the diode, kenapa kita belajar diode. Okay, semua tu you have to know on the theory sahaja. On the calculations tak apa, kita tak tahu. It just for you untuk kalau you suka, boleh je nak belajar. Madam, saya nak belajar, datang jumpa saya, then I can show to you macam mana nak kira. Tetapi as for kita punya calculations, please you need to know how to calculate for chapter 2A on the diode, and then 2D on the Zener diode. Okay. Zener diode, apa ni Zener diode? Okay, this is explanations of diode and Zener diode. Diode is the biasa simple diode. It can use as switch. Ada forward and reverse bias. What happen in forward? Forward, for the diode we have forward bias, reverse bias. Kalau forward bias, it is on. Reverse bias, off. On meaning that we have value for ID, VD. Kalau off, there is no value for ID. VD ada. On, dia short circuit the diode tu, so dia boleh cross lalu. Okay. For reverse, dia open circuit. That is why I dia equals to 0. Sebab open circuit kan, current tak boleh lalu. There is no path. Okay, how the current boleh lalu when there is path? Current tu datang dari mana? From the movements of movement of apa? Terus dia buat muka pelik. Movements of electron. So electrons dia mesti, ingat tak hari tu chapter 1 kita belajar yang ada tank, ada tangki, lepas tu ada air, ada pipe air. Okay, so dia mesti kena ada air, ada pipe yang naik, sebab dia kena flow kan kalau pipe air. Sama juga for the electrons. Electrons, in order to get current flow, dia mesti kena ada closed path. Closed path. Okay, dia mesti kena bertutup pula. Dia kena laluan yang tutup lah. Okay, dia kena close loop. That is how you can get the value of the current. Kalau I equals to 0, maksudnya dia open. Bila dia open, dia putus. Dia tak boleh lalu. Okay, macam mana dia nak lalu current tu? Tak ada jambatan dah. Alright. So, for open circuit, current must be 0. That one is for normal diode. For the Zener diode, we want to, tapi what happened to the diode when it is reverse bias? Dia off. Kalau on juga, mungkin diode tu boleh terbakar. Diode ni dia macam components yang very small. Dia very fragile, senang rosak. Murah je pun, berapa sen je. Okay. So that is why dia senang rosak. And macam mana kita nak, how we want to overcome this problem? We can use this Zener diode, because Zener diode can operate in forward bias, in reverse bias. Okay, remember hari tu when saya lukis IV characteristic, for Zener diode dia ada sampai certain value. Okay, kalau for Zener lah. This is for reverse bias. Okay. Diode can conduct current only in one direction, whereas for Zener diode allows the conductions for both directions, meaning that forward bias and reverse bias. Okay. Tengok kat sini dia tulis, normal diode will be damaged. Maksudnya dia terbakar lah. Kalau in simple word, kalau you guys mesti biasa dengar fuse terbakar, it is actually the diode terbakar. Okay. Kalau large reverse current flow. Tetapi for Zener diode dia tak akan rosak until one value. Dia ada limit dia juga. Kalau exceed the limit dia boleh rosak juga. Tak adalah sampai ribu-ribu dia tak rosak. Okay. It can conduct for both direction. It has Zener voltage or breakdown voltage where it starts to allow current to flow at reverse direction. Okay, provide the reverse current that do not exceed specific voltage or limit. Dia ada limit dia lah. And how to get the Zener and Zener diode? Sebenarnya diode tu datang dari mana? Okay, yang kita belajar chapter 2A tu kita ada P and N. Okay, when we put this P and N together, dia jadi PN junctions. Daripada situ kita boleh dapatkan ni kan, ni P, ni N. Lepas tu kita boleh jadi diode, positif, negatif. Okay, ini from the normal diode. Kalau kita nak jadikan Zener diode, in order to get Zener diode, macam mana kita nak dapatkan the P and N? Apa yang kita inject dekat dalam material tu mesti berbeza. Depend on the purpose lah. Contohnya datang order, saya nak diode biasa. Okey, dia pun buat. Letak P50, N50 contohnya. Datang lagi satu order, I want Zener diode. Dia tak boleh guna the ratio dah. Dia kena guna formula lain dah. Okey, depend on the doping process dia tu. Okay, in order to get the Zener diode. Number 4 punya point, diode are normally used for rectification. Dekat dalam rectifier tadi. Okay, whereas Zener diode used for voltage regulation. Voltage regulation yang last kali kan, dekat dalam power supply kan, before it goes to output DC tu. Mana gambar tadi? Oh, bukan. This one. Okay. Diode dekat sini. Zener diode in here. Zener diode dekat dalam voltage regulator. Why? Because kadang-kadang kat sini kita takut dia jadi short, electric shorts. Ataupun dekat dalam tiba-tiba diode salah, sebelum pergi voltage regulator, saya tulis 1, 2, 3, 4. Sebelum pergi number 4, maybe one element dekat dalam number 3 rosak. Boleh jadi satu kapasitor dia dah tak function. Ataupun one connection terputus tiba-tiba. Bila benda yang melibatkan connection kecil-kecil ni boleh je jadi kan. And then instead of we have forward bias, tiba-tiba dah jadi reverse. Okay, tu yang guna Zener. Kalau tak ada Zener, terus sambung dengan handphone contohnya. Handphone ke macam tu lah. Terus sambung dengan handphone. So kalau tak ada Zener, handphone yang rosak. Bila ada Zener, Zener yang akan cut dulu. Tu yang tugas dia. Instead of TV kita terbakar, ataupun plug point dia tu je yang rosak. You nak yang mana? So kalau plug point, kita just boleh tukar plug dia tu je kan. Okay, itu yang point dia tu dekat dalam Zener ni. Okay. Okay, in summary, while both standard diode and Zener diode are semiconductor devices with the PN junction, but then have different purpose due to the characteristic. Okay, you guys boleh baca kat sini. Especially in applications where a stable reference voltage is required. Normally dekat dalam applications kita pun apa-apa saja memang kita nak stable reference voltage, stable output. Kalau output handphone nak 5, sekejap 5, sekejap 4, macam mana? Kalau kita pakai AC signal, dia kan ada variations value kan. AC signal kan macam ni kan. So kalau dekat sini bukan maximum value. Kalau sini maybe 5, yang sini mungkin 3 kan. So dia macam tak stable lah. Whereas input untuk devices kita dia nak kena fix. Kalau 5 je. Kan? Okay. Apa lagi? What else? Okay, ini adalah in the Zener diode yang saya conteng tadi. Dia ada forward. Sorry, this is forward. This is reverse. Okay. Simbol for Zener diode dia lain sikit kan. Dia macam ni. Dia ada macam ni atau macam ni. Hujung dia tu. Kalau diode biasa dia gitu je. So for Zener kita kena tambah ni sikit. Okay. Zener breakdown kat sini. Yang kawasan ni. Kalau diode biasa dia dah rosak lah. Since this one is for Zener diode, so dia boleh cater on this shaded area juga. Okay. Zener breakdown occurs in heavily doped semiconductor diode, specifically designed to operate in the breakdown region. Dia memang design untuk kalau forward bias dia boleh operate, in reverse bias pun dia boleh operate in certain value. Sampai limit dia stop juga. Mengantuk pergi toilet. Boleh bangun pergi toilet. Okay, yang ini if you guys baca, the heavily doping of Zener diode cause the device to have much narrow depletion layer. Depletion tu yang saya lukis this one. Depletion layer tu kat mana? Katakanlah this one is N, this is P, yang tengah ni kan. Kalau N dia ada negative electrons, kalau P dia ada hole kan. Okay, so this is the depletion region, depletion layer tu, yang tengah tu. Okay. So this one kan datang daripada doping process yang kita inject dengan impurities nak jadi extrinsic semua tu kan. Okay, so that is the process. Kalau nak buat Zener, dia kena tambah dengan benda lain. Bukan benda lain lah, ratio dia lain. Nak buat diode biasa, ratio dia lain. Okay. And dia akan relate with the covalent bond of the producing electrons and holes semua lah. Okay. Okay, this is on the Zener breakdown. Remember Zener breakdown yang dekat kawasan sini, kat reverse bias. Zener breakdown occurs in heavily doped semiconductor, specially designed for breakdown region. And that one is operate in reverse bias. Okay, dia akan relate lah in reverse bias. Dia akan occur breakdown, Zener breakdown. And then dia punya voltage is the breakdown voltage value. Until satu limit dekat sini, baru dia akan rosak. Kalau exceed lagi, Zener tu akan rosak lah. Diode tu akan rosak juga. Okay, in this region, the diode experiences a rapid increase in reverse current. It is reverse bias kan? So, the current pun reverse current lah. Okay. Maintaining a relatively constant voltage drop across the terminal for the Zener voltage. Ini usage dia for voltage regulator. Due to ability to maintain a stable output voltage despite of the variations in the input. Okay, avalanche breakdown kat sini. Okay, this is Zener breakdown. Yang awal Zener breakdown. Avalanche breakdown yang lagi belakang. Maksudnya when further decrease of the voltage, ni kan lagi negatif. Further decrease of the voltage, dia akan occur avalanche breakdown. Okay, this is process dia lah when in the doping process. Ionizations of the covalent bond by minority carrier. crossing the junction. Reverse breakdown in the diode occur at a voltage more than 5. Maksudnya kalau kat sini 5, kat sini is lagi besar lah, negatif. Sebab negatif forward bias, reverse bias kan. So it is negative value. Okay. And this is symbol for Zener diode. And then for the Zener diode, kita boleh dapat dia punya Zener voltage. This is just explanations for the Zener diode for avalanche. Okay, yang inilah dia relate with the depletion region. Bila kita terbalikkan this one. Okay. Sudden increase in electric current may permanently destroy the normal diode. Kalau diode biasa, dia akan rosak. However, for Zener diode may not be destroyed because carefully designed to operate in avalanche breakdown regions. Di mana when it is in reverse bias. In reverse bias. Kalau normal diode akan rosak. For Zener, it can operate. Diode lain akan rosak. Okay. Avalanche breakdowns occur in Zener diode with Zener voltage greater than 6 watt. Kat sini lah. If it is less than 5, lebih kurang lah 5 to 6 tu dia punya threshold. Kalau 5 dia adalah Zener breakdown. Kalau more than 5 to 6, dia adalah avalanche breakdown. Tapi normally sampai 6.3 je. Okay, mungkin after this, bila dah teknologi makin canggih, dia boleh increase lagi lah the value. Okay, remember this is for reverse bias. Bila reverse bias, the value is negative. Okay, tapi kadang-kadang dia tak tulis negatif. Cuma bila kita lukis in this IV characteristic ni, kita tahu position dia adalah negatif kan, because negative side. Okay. Okay, this is for avalanche. This one is for Zener. Kalau you tengok from here, for avalanche breakdown, dia punya wide depletion region. Sebab dia further decrease for reverse bias. Dia proceed lagi for reverse bias. Lagi reverse bias. Okay. For the Zener breakdown, kat sini dia tak wide. Not as wide as the avalanche breakdown. Yang ni kan. Okay, this one is around 5 watts. This is more than 5. Maksudnya negatif lah. Okay, this one dalam lebih kurang 5 in reverse bias. Okay, you guys boleh baca lagi detail dia punya explanations. For this Zener breakdown, due to the movements of the carrier in depletion region. Okay, due to the movements of the carrier in depletion region, this one. Tetapi for this one, for avalanche, due to the collisions of the carrier produce kinetic energy. Okay, this one, avalanche, due to the collisions of the carrier, pelanggaran of the carrier. Okay. And then this one is lagi wider. This is narrower. Dia punya depletion region and due to the movements of the carrier. Okay. Avalanche breakdown caused by impact ionizations and collisions. For avalanche. For Zener, due to the movements. Zener movements, avalanche collisions. Zener pergerakan of the majority carrier. For avalanche, pelanggaran. Okay. Okay, this is for voltage regulator yang kita dah belajar tadi. In the voltage regulation circuit, kita apply the Zener. This is Zener diode. Okay, dekat dalam voltage regulator. Okay, for voltage regulator, normally mesti kena ada resistor, variable resistor. Ataupun that one is load resistor. Okay. And for voltage regulator, voltage regulator, dia punya efficiency dia V no load minus V full load over V full load, this whole thing multiply with 100. That one is voltage regulator punya percentage. And kita kena tahu when we no load, OAD must be greater than we full load. We full load this one lah, because this is variable resistor. So kalau full load, kita mesti letakkan value of the resistor at the maximum value. Okay. Kalau no load, maksudnya minimum. Full load is maximum. Okay, these types of circuit, this voltage regulator, we want to eliminate the ripple voltage. Commonly used in power engineering to describe the percentage of voltage difference between no load and full load voltages, distribution line, transmission line and the transformers. Oh, ni yang tadi. Okay, voltage regulations equals to V no load minus full load over V full load. Okay, yang saya tulis kat atas tadi, this one. Okay, stability. Voltage regulations help to ensure the stability and reliability for the electrical supply. Apa output power yang kita nak. And voltage drop compensations. Voltage drop can occur due to resistance and impedance. Okay, katakanlah kita dah ada one circuit, tetapi tiba-tiba satu parallel circuit ataupun satu parallel circuit tiba-tiba dia cut down, dia open circuit, dia rosak. So dia akan affect the another parallel circuit. Itu yang kat sini, occur due to resistance and impedance. Okay, voltage regulations help compensate for these losses and maintain voltage level. Walaupun ada connections problem in the circuit, tetapi due to this voltage regulator, dia still boleh operate. Okay, tapi still kena pergi lah kat mana yang rosak tu. Tapi sebelum pergi baiki tu, dia still boleh function. For load variations, as the load of a power supply changes, the voltage can fluctuate. Because that one yang kita guna tadi, this is variable resistor kan. Okay, variable resistor. So it can be either naik ataupun turun on the value. Okay, keeps the voltage within the acceptable limit. Since we have the R value ni, dia akan ada R max dengan R min. So voltage pun akan ada voltage max and voltage min lah. But then for the voltage max and min mesti in acceptable range, so that the process ataupun the circuit still can function. If it is exceed the maximum value, diode tu akan rosak juga. Sebab tu tadi kalau you tengok in mana dah? Yang IV characteristic tu, this one, sampai satu limit, after the avalanche breakdown, the diode still akan rosak. Okay, dia tak adalah dia boleh operasi juga even kalau dah exceed the certain value. Okay. What else? Zener regulator ataupun Zener diode. The characteristic drop in almost vertical manner at the reverse bias. And then for the Zener diode, kita ada VZ. VZ is the Zener voltage. So nanti bila kita buat kira-kira, you guys akan jumpalah all this Zener voltage. VZ, kita ada VZ, kita ada IZ. Okay, Zener voltage and the Zener current. Okay, this make Zener diode a good voltage regulator in the circuit. Okay, ini adalah dia punya apa ni, kira-kira dia. So nanti this one kita akan masuk in next class. Kita ada lagi half an hour. Saya tak siap lagi buat soalan kalau nak main quiz.